Hello everyone, welcome to lesson 3.1, Abstraction and Generalization. After this lesson, you'll be able to define abstraction and generalization in context of computer science and use these concepts to improve your program. You'll also be able to build custom command blocks in Snap. We have been using the blocks provided by Snap or predefined in Snap till now, but we are going to see how to create our own today. Today's plan. We're going to start with a do now activity, move on to lecture, then we're going to see a demo on how to create custom blocks using Snap, and then we're going to take a look at the lab, which is drawing shapes again. So this time we're going to do it using the custom command blocks. And finally, we're going to reflect on what we learned today. In this do now activity, you're given with a special kind of map called a tube map, which shows all the underground highways or underground pathways between the major attractions in a city. You are a tour guide, a hotel tour guide, and tourists staying in your hotel are expecting you to take you take them on a tour. Now, can you plan a route starting at the hotel so that tourists can visit every tourist attraction just once and be back to the hotel? Here, the problem is you can only visit each of the tourist attraction, one of these attraction only once, and you should not miss anything. And uh, you should start at hotel and get back to the hotel at the end of the tour. In order to devise this algorithm, you should try and work it out by placing a smiley piece on the hotel and moving it from location to location, following the black lines and looking for a route that works. After you have figured out a route, you should write it down as a series of instructions. For example, you can say start at hotel, go to science museum, go to toy shop, go to warship, and so on. Now, after you have successfully written down your algorithm as a set of steps, you should test your algorithm to make sure you have a correct solution. We don't actually want to do a tour and find at the end of the day that we missed something important out and have to deal with angry tourists. Now, in order to test your algorithm or to evaluate your algorithm, you should do a dry run or you should trace your algorithm. This just means follow the steps of the algorithm on a paper and place a tick mark on each of the attractions that you visit. So when you are back at the hotel, each of the attractions should have only one tick mark and none of the attractions should be empty. So every time you visit an attraction, you put a tick mark on it. If you visit it twice, you put two. So ideally, your dry run or your trace should have one tick mark in each of these locations. But if you look at hotel, you can see that if you are a hotel, you should put a tick mark at first, and then if you come back, you'd probably put a tick mark again. So hotel might have two tick marks, or you can actually start from hotel and go back to hotel. So that's a special case over here. Now let's pause this video for some time and then work out on your solution, and I'll share one of the solutions that I came up with. Here is one of the solutions to the problem. We started from hotel, went all the way here, and we're using this route, go back to the hotel. So if you see these arrows point to the location that you're going to, and you're only visiting all of these attractions once, and you're not repeating anything. We're not repeating anything here. So the route that we came up with is a sequence of instructions that can be followed to visit every tourist attraction and get back to the start. It's a simple algorithm, and your algorithm could be different from mine since this problem can be solved in a different way. I went to the science museum first, but you could go to zoo or cathedral first either way. If all the requirements of your problem is met, your algorithm is complete. It's correct. Now, since we have this algorithm, now we can hand over this algorithm to anyone and they can follow this set of instruction to make sure that they take the tourists to all major attractions and not miss anything or repeat anything. This problem was made easier to solve because of the way we represented the data as a diagram. So since we have a diagram, it's easier for us to visualize and see things, right? The tube map, this map provided over here is a special kind of diagram called a graph. A graph to a computer scientist is a series of dots and lines. So these dots are called nodes, and these lines that connect these two nodes or the dots are called edges. The nodes of a graph represent something about the data that we are interested in. For example, the tourist attractions over here, and the edges show which nodes are linked in some way that we are interested in. In our case, we're interested in tourist attractions and which ones are linked to each other by the underground connections. We aren't interested in anything else about the places, so we ignore everything else. So, for example, there could be a gas station over here, there could be a church here. We are eliminating all that and we're just focusing on what we really need. This graph is an abstraction of the real city. We have hidden all the extra detail that we don't need in creating the graph. This makes the information we are interested in much clearer. So by abstracting all this data from everything else, we're making our graph easier to see and easier to devise our algorithm. Graphs are often used by computer scientists for various purposes. You can also use graphs in artificial intelligence to create different kind of solutions or for different kind of problems. Now, this kind of problem or this kind of algorithm in computer science is called Hamiltonian cycle, where you can visit each node once and not miss any nodes in a graph. If you are interested in these kind of algorithms, you can also look at similarly, you can look at Knight's tool. So over here, if you have ever placed chess, you can you know that knights move in a special way. So you'd have to find a way where the knight moves and goes to each of the square blocks over here without repeating anywhere. So this is another kind of algorithm. Algorithms are really beautiful and they make our life really easier. In our next video, we're going to take a look at the concept of abstraction and generalization. We're going to look at a video from Dr. Dan Garcia from UC Berkeley. He's going to explain what abstractions and generalizations are in computer science. So let's go to the next video.